how do we get the slope of the curve defined by these two parametric equations in terms of t? One way we could do it is, we know that from what we just saw by eliminating the parameter that y is 4 square root of x minus 3, take the derivative of that, and what are we going to get? We're going to get 2 over the square root of x minus 3, and then we can figure out the derivative in terms of y and x, and then we can figure out what t is from the x or the y coordinate, and somehow get the derivative in terms of t. That's a lot of trouble. We don't want to do that. Very simple idea. If we interpret t as time, okay, now we don't have to interpret it as time, but we choose to interpret it as time. So if t is interpreted as time, then what does the derivative of the x function tell us? What does the derivative of the y function tell us? Well, if x is the position in the x direction, then the derivative with respect to t is the velocity in the x direction. Now, whether t stands for time or not, the derivative of x with respect to t is the rate at which x is changing with respect to t. So take any value of x, take the corresponding point on the graph, and the dx dt, the derivative of x with respect to t, is how quickly the x coordinate is changing with respect to t. You can think of that as the x velocity, if t is interpreted as time. And the derivative of y with respect to t is how fast y is changing with respect to t. So that if you create the vector, v of t equals the derivative of x with respect to t times I plus derivative of y with respect to t times j, and those derivatives would be what? Just 2t, 2ti, and derivative of 4t is just 4, so it would be 4j. That's what you have. You have this vector, which could be interpreted as dx dt times I, which is 2t times I, and this vector, which is your dy dt j, which is just 4j. The resultant of these two vectors is just the v of t vector that you see here. You can interpret that as a velocity vector, or you can just interpret that as the rate of change of position on this graph with respect to t. Okay, what's the slope? Well, the slope of this thing is just the j component divided by the I component. Okay, so that's rise over run. This vector has a rise of 4j, has a run of 2ti. So the rise over the run of this vector is 4 over 2t, which is 2 over t. Okay, that's the slope. And of course, the 4t, the 4 is just your dy dt, the 2t is just your dx dt. So all you're doing here is dividing your dy dt by your dx dt. Again, why do you do that? Well, the rate at which the position on this curve is changing has a y component and an x component, dy dt, dx dt. In general, this is going to be dy dt I plus dx dt j. So I could make a little note here, your v of t is dx dt I plus dy dt j. So slope is rise over run, which is what? Rise would be your j component, run would be your x component, your I component. So you have dy dt over dx dt. So you need to lock in that insight. Okay, now in a minute we're going to figure out arc length.